Welcome back to Meteorology Matters, where we explore the fascinating world of weather and its impact on our lives.
Yeah.
Today we're diving into a topic that might just surprise you.
Okay.
The power of wind and how sometimes it's not the massive hurricanes that cause the most damage to buildings, but something else entirely.
You're right. It's not always the big headline-grabbing storms that pack the biggest punch.
Yeah.
Sometimes those fast-moving lines of thunderstorms
Right.
can cause more damage to skyscrapers than a hurricane.
Exactly. And we've got a real head-scratcher of a case study to unpack today.
Oh, okay.
Houston, 2024.
Right.
We had a derecho, which is a widespread windstorm, rip through the city in May.
Mm-hmm.
Then just a few weeks later, Hurricane Beryl made landfall.
Okay.
The crazy thing is both events had similar peak wind gusts, but the damage they caused was dramatically different.
It is a real puzzle, isn't it?
Right.
And it shows that wind speed alone doesn't tell the whole story.
Yeah.
We need to consider other factors like duration, direction, and how those winds interact with the buildings themselves.
Okay, so let's paint a picture for our listeners.
Right.
It's May 2024 in Houston, and this derecho rolls through.
Okay.
It's like a line of intense thunderstorms packing some serious straight-line winds.
Right.
Then in July, Hurricane Beryl comes along.
Mm-hmm.
Both events had peak wind gusts in the same ballpark.
Okay.
But here's where it gets interesting. The damage tells a very different story.
Okay, so what do we have?
Well, if we zoom out a bit,
Okay.
we have to remember that the impact of wind on a building
Yeah.
isn't just about how strong the wind is, but how long that force is applied and the angle at which it hits.
Right.
Think about pushing on a tall object. A steady, sustained push is different from a series of rapid jabs, right?
That's a great analogy.
Okay, let's start to see where you're going with this.
Yeah.
Let's look at some real-world examples to illustrate this.
Okay.
One that stands out is the Chevron Building Auditorium.
Not right.
This skyscraper took a beating during the derecho. We're talking dislodged facade panels, shattered windows,
Mm-hmm.
the whole 9 yards. But when Hurricane Beryl hit barely a scratch.
That's so interesting.
Now, why the difference?
Mm.
Well, the Chevron Building Auditorium is located right across from another tall building.
Okay.
And this is where the concept of wind channeling comes into play.
Ah, I see.
Think of it like those narrow city canyons where you feel the wind whipping through.
Yeah.
When buildings are close together, they can create these wind tunnels
Right.
that intensify wind speeds and pressure in very localized areas.
Fascinating.
So it's not just the wind itself,
Yeah.
but how the surrounding buildings shape and amplify its force.
Exactly.
That makes sense.
Yep. And we see a similar pattern with the Centerpoint Energy Plaza.
Okay.
The derecho caused concentrated damage at a specific corner of the building, likely due to channeling effects amplified by those nearby structures.
Yeah.
Hurricane Beryl, on the other hand, caused minimal damage.
So we're noticing a trend here.
Yeah.
Localized damage from the derecho, particularly in areas where wind channeling seems to be a factor.
Exactly, and this really emphasizes how those sudden bursts of wind from a derecho can exert intense pressure on specific parts of a building, leading to that concentrated damage.
Yeah.
It's different from the more sustained, widespread wind load of a hurricane.
All right, let's move on to the El Paso Energy Building.
Okay.
And I bet you can guess what happened.
Let me guess.
The side facing another tall building boom. Most of the damage happened during the derecho.
Wow.
Hurricane Beryl, minimal impact.
It's like a textbook example of how a building's location and orientation relative to its neighbors and the wind direction can drastically influence how it weathers a wind event.
You know, it's kind of mind-boggling that these buildings are designed to withstand wind speeds up to 67 meters per second.
Yeah.
You'd think they'd be able to handle anything, but then the derecho comes along and it shows us that there's more to the story.
Right. It challenges our assumptions about building resilience.
Yeah.
And it underscores the importance of not just designing for peak wind speed, but truly understanding the unique characteristics of different wind events.
It's a good reminder that Mother Nature always has a few surprises up her sleeve.
She does.
In fact, after the derecho, they did an assessment of 18 downtown buildings and found something like 3,250 broken windows.
Wow.
That's a lot of glass.
That's a staggering number, and it really highlights the potential for economic disruption and safety concerns when these events hit.
Okay, so we've seen the damage, but let's dig into the why. What makes the damage from the derecho so different from the hurricane?
Well, we've talked about wind channeling,
Yeah.
but there are other factors at play here.
Okay.
For starters, let's think about the nature of the wind itself.
Okay.
Hurricanes have those sustained winds that push on a building fairly consistently.
Mm-hmm.
Derechos, on the other hand, are marked by these sudden, powerful bursts of wind called downbursts.
Downbursts.
Yeah.
Fill us in on those.
Imagine a giant bucket of water suddenly dumped from the sky.
Okay.
That's kind of what a downburst is like.
All right.
It's a column of air rapidly descending from a thunderstorm, hitting the ground and spreading out like a fan.
Okay.
They cause these sudden changes in wind speed and direction near the ground, which can put immense localized pressure on building facades.
So it's like a sudden concentrated blast of wind.
Exactly.
No wonder it causes so much damage.
And those rapid shifts in wind pressure can be particularly damaging, especially to structures that aren't designed to handle that kind of localized force.
So we've got the wind channeling the sudden force of downbursts.
Right.
What else is contributing to this damage disparity?
Well, the design and construction of the buildings themselves play a crucial role.
Okay.
The materials used, the quality of construction, even routine maintenance.
Right.
All of these factors impact how well a building stands up to wind, whether it's a hurricane or a derecho.
Interesting.
A well-designed and well-maintained building will fare much better no matter what Mother Nature throws at it.
So it's a combination of the wind event itself and how the building is designed and built to resist it.
Exactly.
Fascinating.
Yeah.
Now I understand there's a way to actually study how wind interacts with structures. Something called wind tunnel testing.
You got it.
Okay.
Wind tunnels are incredible facilities where researchers can create scaled-down models of buildings and subject them to different wind conditions.
Wow.
They can then measure the pressures and forces on the model to see how it would respond in a real-world scenario.
That's so cool. It's like a mini hurricane simulator, right?
Exactly. And there was a really interesting study done recently
Oh, wow.
at the Wall of Wind Experimental Facility at Florida International University.
Okay.
They simulated both the kinds of winds you'd see out in the open ocean during a hurricane and those intense downburst winds from a derecho.
And they tested a model of a tall building under both conditions.
They did, and they also looked at how the presence of nearby buildings impacted the results, which is key to understanding those wind channeling effects we've been talking about.
What did they find?
What they found was that the downburst simulations created much higher negative pressures or suction on the sides of the building compared to the hurricane-like winds.
Oh, wow.
This lines up perfectly with what we saw in Houston after the derecho.
So the wind tunnel basically confirmed that those sudden powerful downbursts can exert incredible suction on buildings,
Precisely.
potentially ripping facades right off.
And they also discovered that having another building upstream, basically in front of the test model relative to the wind direction, significantly increased the suction on the test model's windward wall.
Wow.
Again, this really highlights the importance of wind channeling in those dense urban environments.
So these wind tunnel tests are giving us real insights into how wind behaves around tall buildings, especially in those crowded downtown areas.
And it helps explain why those localized wind events like derechos can be so destructive even when the wind speeds aren't as high as we might expect.
This is all incredibly insightful.
Yeah.
It really makes you think differently about how we design and build in the face of increasingly unpredictable weather.
It certainly does. You know, this case study in Houston is a stark reminder that we need to rethink our approach to building design, especially in urban areas.
Absolutely. We'll be right back after a quick message from our sponsor.
All right, sounds good.
Don't forget to follow meteorologist Rob Jones on Instagram. His handle is just meteorologist.
Okay.
On TikTok at TV Meteorologist.
Got it.
And on YouTube, follow Rob Jones Hurricane, where you can also find the Meteorology Matters podcast playlist.
Awesome.
See you in just a bit.
Sounds good. Welcome back to Meteorology Matters. Before we took a quick pause, we were discussing how a derecho in Houston caused surprisingly more damage than a hurricane, even though they had similar peak wind speeds.
And we were starting to unravel why those wind channeling effects and powerful downbursts really seem to make a difference.
Now let's shift gears a bit and think about what all of this means for you, the listener, and for cities in general.
Yeah, I think most people just assume that if a building can withstand a hurricane, it's good to go no matter what.
That's a pretty common assumption, but this Houston case really throws a wrench in that thinking. It forces us to reconsider how we approach building design, especially in densely populated urban areas.
So are we saying that we need to start designing buildings specifically for derechos?
It's not necessarily about designing for one specific type of storm, but about designing for overall resilience. We need to broaden our perspective and consider a wider range of wind conditions, including those sudden localized gusts that can be even more destructive than sustained winds.
Okay, so we need to be thinking about those extreme short-duration wind events, even if they don't happen as often as hurricanes.
Exactly. And we have to factor in the urban environment. How will wind flow around buildings? Where are those wind channeling hotspots going to be?
It seems like wind tunnel testing would be super valuable for figuring all of that out.
Absolutely. Wind tunnel testing allows us to visualize how wind interacts with buildings and pinpoint those vulnerable areas that might be susceptible to concentrated pressures from downbursts or channeling effects.
So it's not just about making buildings stronger across the board,
Hmm.
but about understanding those specific pressure points and designing accordingly.
And it's about selecting materials and construction techniques that can handle those forces.
What about buildings that are already standing? Are there things we can do to retrofit them to better withstand these localized wind events?
That's a great question, and it's something that's becoming more and more relevant as we realize just how impactful these events can be. Retrofitting could involve a range of strategies, from strengthening connections and anchors to adding wind deflectors or even redesigning certain parts of the facade.
So we're not just talking about new construction, but also about reassessing and potentially upgrading existing structures. That's a huge undertaking.
It is, but it's necessary if we want to make our cities more resilient. We need to adopt a more holistic view of wind resilience, one that considers the entire lifespan of a building and the reality of a changing climate.
So to recap, it's not just about wind speed. It's about understanding the nuances of different wind events and how they interact with the built environment. It's about designing for resilience, not just for a specific storm. And it's about considering the long-term implications for both new and existing buildings. Did I get all of that?
You nailed it. It's a real paradigm shift in how we think about wind in buildings. And the Houston case serves as a potent reminder that this is an issue we can no longer afford to sweep under the rug.
This is some heavy stuff.
Yeah,
It makes you realize how much we still need to learn about wind, its impact on buildings.
there's always more to learn, and that's what makes science so fascinating. It's a constant process of discovery, and as we gather more data and refine our understanding, we can create safer, more resilient structures for the future.
That's a great way to look at it. It's not about being overwhelmed by the challenges, but about embracing the opportunity to learn and innovate. So speaking of the future, what are some of the key research areas that you think will be most important in advancing our understanding of wind and building?
There are a few really promising avenues of research that I'm particularly excited about. One is the continued development of advanced wind tunnel testing techniques. We're now able to simulate increasingly complex wind conditions like downbursts and tornadoes with greater accuracy. This gives us a much clearer picture of how those extreme winds interact with structures and the kinds of damage they can inflict.
So those simulators are becoming more and more realistic, which means better data to work with.
Exactly. Another exciting area is the use of computational fluid dynamics, or CFD for short. This is a powerful tool that allows us to model wind flow around buildings in incredible detail. It's like running virtual simulations to see how different building designs, materials, and configurations perform under various wind loads.
So it's like a virtual wind tunnel, but even more detailed and versatile. That's amazing.
It really is. And it lets us test a much broader range of scenarios and design options than we could with a physical wind tunnel.
It sounds like the future of building design is going to be incredibly high tech.
It most definitely is. And then there's the growing field of field measurements. This involves using sensors and instruments to collect data on actual wind events as they unfold in real time. This real-world data is invaluable because it allows us to validate our models and improve our understanding of how wind behaves in different environments.
So we're not just relying on simulations and models, we're going out and gathering real-world data to confirm those findings.
That's right. It's a multi-pronged approach. And the convergence of these different research areas is giving us incredible insights into wind and its impact on the built environment.
It's remarkable to see how this field is evolving.
Yeah.
It feels like we're on the cusp of some major breakthroughs in how we design and build for wind resilience.
I agree. And the Houston case is a powerful reminder that this research isn't just theoretical. It has very real implications for safety economics and the long-term sustainability of our cities.
It's a lot to think about, and it definitely highlights the need for ongoing research and innovation in this field. We'll be back after a short break to explore some of the exciting ways that architects and engineers are putting this knowledge into practice. Stay with us. Welcome back to Meteorology Matters. We've been talking about the surprising power of wind and how events like derechos can challenge our assumptions about building resilience. But now let's shift gears and talk about solutions. How are architects and engineers using this knowledge to create buildings that can truly stand up to the wind?
Get ready for some serious innovation because the world of wind-resistant design is getting really exciting. Architects and engineers are using wind tunnel testing and computational fluid dynamics, not just to test finished designs, but to inform the entire design process from the very beginning.
So instead of just checking if a building will survive, they're actually using wind to shape the building itself.
That's exactly right. Think about the aerodynamic shape of a car. It's designed to cut through the air and minimize drag. We can apply those same principles to buildings using shapes that reduce wind loads and make the building more efficient.
I've noticed that some modern skyscrapers have those interesting curves and twists. Are those designed with wind in mind?
Absolutely. Those aren't just aesthetic choices. They're often strategically placed to redirect wind flow, reduce pressure on certain areas, and minimize the overall forces acting on the building.
Wow, so they're turning buildings into giant wind sails, but in a good way. What about the materials themselves? Are there any new innovations in that area?
Definitely. We're seeing some incredible advancements in building materials. For example, there are new types of high-strength glass that are much more resistant to shattering, even under the extreme pressures from those sudden downbursts we talked about.
Stronger glass aerodynamic shapes. What about the way buildings are actually constructed? Any cool new developments there?
There's a growing emphasis on what's called flexible design. This means creating buildings that can move and sway slightly with the wind rather than being completely rigid.
Wait, are you serious? Buildings that actually move with the wind, isn't that a bit, well, risky?
It's not like they're going to be dancing in the breeze, but they have a certain degree of flexibility engineered into their structure. This helps dissipate the energy from the wind, reducing the stress on the building as a whole.
So it's kind of like bending with the wind instead of breaking. That's pretty ingenious. It's like
Oh,
taking a cue from nature trees. And plants sway in the wind. They don't try to resist it completely.
you got it. It's
Yeah.
a fascinating approach that's inspired by the natural world.
So we've got stronger materials, aerodynamic designs, and even buildings that can move with the wind.
Mhm.
What's next? What's on the horizon in terms of really futuristic ideas?
Well, hold on to your hats, because this is where things get really wild. Researchers are experimenting with things like active facade systems. These are facades that can adjust and adapt to changing wind conditions in real time.
Okay, you're going to have to explain that, one, buildings with facades that change shape with the wind. That sounds like something straight out of a science fiction movie.
It does sound like sci-fi, but it's becoming a reality. These active facades use sensors to detect wind speed and direction and then adjust their shape or orientation to minimize the wind load on the building.
So buildings will literally morph and transform to withstand the wind. That's incredible.
That's the goal. And even more futuristic, there's research being done on using wind energy to power buildings themselves. We could potentially see skyscrapers with integrated wind turbines or even entire facades that generate energy from the wind.
Now that would be truly amazing. A skyscraper that not only withstands the wind, but actually harnesses its power. We've come a long way from those shattered windows in Houston.
We have. It's a vision of a truly sustainable future where buildings work in harmony with the forces of nature.
This has been such an eye-opening conversation. We started by exploring that surprising derecho in Houston and how it challenged our assumptions about building resilience.
We learned about wind channeling downbursts and the importance of understanding how different types of wind events impact the built environment.
And then we took a trip into the future of wind-resistant design, where architects and engineers are pushing the boundaries of what's possible, creating buildings that can withstand and even harness the power of the wind.
It's clear that our growing understanding of wind will continue to shape the future of architecture and engineering.
Well, that's a wrap on today's episode of Meteorology Matters. A big thank you to our expert guests for sharing your incredible insights. And to all of our listeners, thank you for joining us. Don't forget to follow meteorologist Rob Jones on Instagram. His handle is meteorologist, on TikTok at TV Meteorologist, and on YouTube follow Rob Jones Hurricane, where you can also find the Meteorology Matters podcast playlist. Until next time, stay curious about the world around you.